So our review of Chemistry 2 Module 1, alright, with the question paper. Let us go. We're asked firstly to give the IUPAC name of compound A whose molecule is shown below. Raise your hand if you wish to give an answer. Go ahead. Bromohexane. Do we all agree with 3-bromohexane? 1, 2, 3, 4, 5. Ah! Do we agree with what's happening? Go ahead, Anushka. Pentane. Okay. 3-bromopentane. Interesting. Alrighty, so let's have a look at this, right? So we have 1, 2, 3, 4, 5. It doesn't matter where we count from 1, 2, 3, 4, 5. Bromine will always end up back on the 5th carbon. This is fine. This is lovely. 1 mark. And we see chemistry 2 is difficult. Let's move on with our lives, right? A. Well, part B. A hydrocarbon with molecular formula C6H14 is known to have 5 structural isomers. Draw the structures of each of these isomers in the space provided. No, I didn't put any space here, right? But let's go. What are the different isomers that we can find from C6H14? We can draw them on the empty spaces here. C6H14. First, we could note that there will be an isomer, a straight chain, 1, 2, 3, 4, 5, 6, right? That counts as one isomer. Alrighty. What else could we have? It's 5. So the formula is C6H14, so it needs to be 6. Oh, okay, alright. So hold on. Let's name them actually. Let's create a list of names then. Because that would be a little bit easier. Alrighty. So the first one, alright, go ahead with your name. You just have regular hexane, or what we call N-hexane. Regular hexane. What else would you have? 2,3-dimethylbutane. 2,3-dimethylbutane. Okay, that's fine. Anything else? What are the others? Methylpentane. Actually, methylpentane is one of my favorite names. Alright, let's move on. What else? We can draw them to show that they're different after. Already? Anybody else has another suggestion as to one isomer that we haven't looked at yet? We have 3 so far, which are all different. 1-methylbutane, 3-methyl. These are different. Two dimethylbutane. Alright. Alright, so let's look. Your entire thing is butane, right? So 1, 2, 3, 4. Alright? You said dimethyl, right? So 2,2-dimethyl. So you have something like this. This is what you're saying? That's 2,2 dimethyl butane, right? Mm-hmm. On the left side. Okay. Alright, hold on. This is the structure you're referring to? Alright, so hold on. Let me get clear to what you're saying. So this is what we draw previously, right? What is a new structure that you're proposing? You propose that we have a structure like this. Right? Mm-hmm. Mm-hmm. Or something like this. Oh, it has isn't a branch, it's the same thing. Yes. Okay, so it's the same butane. Mhm. 2,3-dimethylbutane is different from 2,2-dimethylbutane, which is from 3-methylpentane. We need another. What is the last isomer? Go ahead. One. Okay. Alright, so one ethyl you said, and then you have two methyl what? Pentane? That makes sense. Propane makes sense. Okay. Come like pentane doesn't make sense. Propane. Alrighty. Um hmm. And you're asking or are you telling me? Asking me and telling me are two different things, you know. Okay, so there we have our different isomers. So you just need to draw out the structure for these. And I'm pretty sure you guys are masters at completing your structural formula at this point. At this late in the game, you guys would have already completed that and mastered that. Already, we need to say two IUPAC names. So that's why I write all of them. You can pick any two IUPAC name and put it there. Already? So the IUPAC names there, you should just be able to draw them out. Is there anybody here that sees a name and wants me to draw out the structural formula because they're unsure of how it looks? Clintonil, Austina, Danielle, Divine. You guys are all fine with these names and how to draw these? Already, let's go. Let's move on. All right, I'm so excited. It's just chemistry. All right, write the IUPAC name for the geometric. Why does it say geometrical? Sure, for the geometric isomers or geometrical isomers, I guess. B and C shown below. So what is the name of B? Okay, so we're seeing a trans. Let me actually type it. It's a little bit easier for me to type it than write it. Alrighty. So you're saying that B is trans pent. I prefer trans 2 pentene. But I think you can also have just the trans pent 2 in. That's fine. Let me change that capital T to a common. Alright. What's the name of the next one? Alright, so Daniel, right? So you answered those, right? And after you understand those, right, you can note that chemistry is not hard, right? You know, it's not a because what look here, she just got 2 marks from literally distinguishing trans from cis. That's it. 2 marks. I think a lot of persons just have a mental block to the chemistry because really and truly chemistry is just so sweet. And it's feeling so neglected by you guys. Let's go. Compound B, right, in C1 reacts with hydrogen bromide to yield the Markovnikov product D as an equal mixture of 2 optical isomers. Define the term optical isomer. What's an optical isomer? Go ahead. Mm-hmm. So they're chiral. Alright, so chiral compounds. Mm. You can use that. So superimposable. Why are you saying that definition is wonky? It isn't. I mean that's very true. But this is fine. So they're chiral compounds that are non-superimposable, right? So 2 or more, because we're talking about isomers, so after write 2 or more chiral compounds, right, that are non-superimposable and are optically active, right? You guys look at the concept of ray symmetry. All right, let's just move on. Ray symmetry and L isomer versus a D isomer. And the fact that a L isomer rotates light to the left and a D isomer rotates right, polarized light to the right. Okay. I mean, well, do you need to know that? Well, it's not explicitly stated on the syllabus, but that's literally what optical means. Because okay, the reason why I introduced those stuff, is because when we say a isomer is optically active, right? The lay students will just say, okay, it's optically active and move on with their lives. But you need to introduce ray symmetry for them to understand why we say it's optically active. The molecule can literally bend light in different directions, right? So looking at that. So if they're not explicitly asking this question, we just skip. Well, if they interesting. Alright, let's look at this. Draw the structures of the 2 optical isomers that we were referring to. Alright. So what we're saying now, let me scroll up a bit more. Alrighty. So we're saying that we have the 2 compounds as it's up there. We say compound B reacts to yield a Markovnikov product D. Right? So we must react trans 2 pentene with hydrogen bromide to yield the Markovnikov product and probably the anti-Markovnikov product. Right? Wait, you know what? No. Just the Markovnikov product and then use 2 isomers to get that. So what would be the answer to this? How do we draw the Markovnikov product for D? And we should be aware of how we draw chiral compounds. Go ahead. What do you mean by actually? Okay. What is Markovnikov's rule? Markovnikov's rule: the hydrogen attaches to the carbon bearing the most hydrogen. Alrighty, so we have something like that. But it's kind of weird here, because both carbons that we're reacting have only one hydrogen, right? So it's kind of weird. It doesn't. That's why we create two isomers. Lovely. Alrighty, so let's have this as carbon 1 and let's have this as carbon 2. Let's draw one with carbon 1 as the chiral center. Alright, so we're drawing carbon 1 here. The carbon there. Alright, following. We have CH, CH2, CH3. Alrighty, so we have that there as one group over there. We have the CH3 down here, right? Then we may have something like this. So we may have probably, we're going to have coming out of the page, probably bromine, and then going back into the page we have hydrogen. Alrighty, so the next one now we have to draw the compound now just being optically isomeric, right? So we just need to draw the optical isomer. So what would be the optical isomer to this? They must be non-superimposable. Let me add to that definition down here. Non-superimposable mirror images, right? They must be non-superimposable mirror images. Let me drag this over a little bit. It's really and truly there. Alrighty. Repeat. We're going to switch what? Alrighty. Alright, so let's look at this. So what you're suggesting is that we do something like this. CH3, CH2, CH2. What you're suggesting is something like this. Right? And you probably have the bromine going into the board now. Right? And the hydrogen coming out. Probably have something like that. That's what you're referring to? Okay. Who agrees? Does everybody agree? Does me agree? I'm joking. Do I agree? Do I agree? No, I'm not sure if I agree yet, you know. Alright? I have to really still look because students tend to gaslight people into believing that things are the right answer, so I have to check to make sure that it is fine, that it is dandy, it is okay. It seems okay. What's the name of this compound? What's the name of this compound? This is 2-bromo what? 2-bromo pentane. Okay, go ahead. Alrighty, so we have 2-bromopentane and this is fine. These are the two isomers of 2-bromopentane. And the chiral carbon, which would be which carbon? This, the one in the center, right? So this is the chiral carbon bearing 4 different substituent groups or 4 different groups in general. Alrighty. So let me head out a little bit and okay, what don't you understand? Need you to talk. To say that specifically is what I don't understand. I need to point at it. What doesn't understand? What I just did? You mean drawing the compounds? Oh, you wanna know what the big difference is between them? Alright, so the main difference between the two molecules, right? Oh no, that's not okay. Well, no. Okay, alright, so hold on. Alright, the main difference between the two molecules is that in molecule 1, let me just label them so I can have a point of reference for what I'm referring to. In molecule 1, hydrogen is going back into the board and bromine is coming out at you. In molecule 2, bromine is the one going back into the board and hydrogen is the one coming out of you, right? So they're literally attached to the same carbon, but spatially they are different. So spatially, in one hydrogen is coming out and the other hydrogen going back. Spatially, bromine is coming out in one, and then spatially in another one it's going back, right? So let me see if I can find it. Let me clarify it for you. What was the compound is called? 2-bromo what? Pentane. Let's look for 2-bromopentane and let's settle this immediately. So what a way if I put 2-bromopentane and the wrong compound come up. Alright, but let's look at this. So 2-bromopentane, it is optically active. We know already. We have a SR isomer and it has an R isomer. Alrighty. So we just want to check the isomer specifically. Alrighty. But we have two stereoisomers that come from this, right? Let's look at this specifically. And I like the fact that they looked at this specifically because they actually are two enantiomers as well and they have one-to-one resymmetry. But we're not going to get into all of that, right? So we have these two. So it's chiral. So what's happening here, let me just let me look for the optical isomers of 2-bromopentane. Where are they? Where are y'all? This is it, right? So this is showing the optical isomers of the two. So you can see what's happening here now, how it's different just because of like what direction these are placed at. So non-imposable mirror images or non-superimposable mirror images. I want to find a regular diagram of it as well, of both of them. These are not like good representations of what I'm trying to do. This, right? This is an example of what I just did, right? So they are arranged somewhat in the same way. Alrighty? So you can see that they're non-imposable to mirror images of themselves. So if we were to go back to the topic at hand now, right? What's happening here? They're just arranged differently based off of R and S, right? Hold on, let me simplify something for you. Well, let me not simplify it that way. Let's keep it this way. Let's keep it this way. Alrighty. So we have that there. So just looking at the two different optical isomers in that way. Alrighty, you can draw it without the hash lines as well, right? But really and truly, probably we need practice for isomers. Probably we need the isomer worksheets, and we can go through it. Alrighty. So let's move on. State the color change when observed compound C reacts with bromine. Compound B and compound C are both alkenes, right? So what is the color change when we react bromine with an alkene? What happens? It decolorizes, right? So it changes from dark brown or red brown to colorless. Alrighty, so we have that there, decolorizes, right? Moving onwards now. We haven't even completed number one. Alrighty, let's move on. Name the functional groups highlighted in the compounds labeled A, B, and C. What is the functional group in A? Labeled in A. Go ahead. Didn't hear what you said. Alkene, alright. For B, now we have a what? Hydroxyl, right? Hydroxyl. Alrighty, and the last one is? We're naming the functional group. Well, I mean, well, it's a carbonyl. Group, right? It's just a functional group, it's not saying, what type of compound it is overall, right? It's just looking at the group. So the group specifically here is carbon double bond to O, so it's a carbonyl group. Alrighty. If reagents 1 and 2 in the scheme above, right? Oh, sorry, identify reagents 1 and 2, right? So here in the reaction 1, right? What is reagent 1 here? So look at A and what it produces at B. What is the reagent at 1? Bromine water, I guess. Well, it's bromine. And then for part 2 now, or reagent 2 now, we take that brominated compound and we produce this. What is the reagent there? Anyone? We're just looking at what's happening to the functional group, Potassium permanganate, lovely, right? So it tends to be what? Hot and acidified. We can use that. Hot, acidified, KMnO4, or you could use chromate, dichromate, C2O7. Cr and potassium dichromate, so it would be P, right? Potassium dichromate. Identify the color of the change. Alright, so first of all, from compound A to compound B, what is the color change? So let's see what's happening in compound A and compound B. So from compound A, because you add the bromine, it's going to be dark. It's going to be like a red brown. Compound B should be fairly colorless. Alrighty? So it's really decolorizing. So they identify the color change. It's literally the same thing as before. Red brown,